we will discuss about transmission parameter. Here you see, this is two port network, this is port 1 and this is port 2. In transmission parameter, this input current and voltage, that means V1 and I1 will be a function of V2 and I2. So in transmission parameter, this input current and voltage is a function of output current and voltage. That means this is port 1 and this is port 2. So the parameter of port 2 is a function of the parameter of port 2. Now, how to write this V1 and I1? V2 can be written as the ABCD parameter, that means A into V2 plus B into minus of I2, okay, minus of I2, and I1 can be written as C into V2 plus D into minus of I2. This is the pair of two equation of this current and voltage in terms of ABCD parameter. Now we will define this A, B, C and D parameter. Number 1, if I open circuited this port 2, so condition is if I open circuited port 2 is open circuited. If port 2 is open circuited, then this current will be 0. So here I2 will be 0. I2 will be 0. Now from equation 1, this is equation 1, this is equation 2. Suppose from 1 we can define that A is equals to V1 divided by V2 when I2 is 0. Now what is this? This is ratio of two voltage. Ratio of two voltage when this port 2 is open circuit. That means receiving end is open circuited, and this is called a ratio of voltage. This is V1 by V2. That's why we tell it as the reverse voltage ratio with receiving end as open circuited. Now from equation number 2 we can also write C equals to I1 divided by V2 when I2 is 0. This is the ratio of current to voltage, and current to voltage, it's nothing but a admittance. What is this? Current divided by voltage is called admittance. So this is admittance, but this is I1 by V2. That's why it's called the transfer admittance. The transfer admittance with receiving end as open circuited. So A is called reverse voltage ratio, C is called the transfer admittance, and when this end is short circuited, if you short circuited this port 2, then V2 will be 0. So port 2 is short circuited. If you short circuited this port 2, then V2 will be 0. If V2 0, then from equation number 1 we can write that B is given by V1 minus I2 when V2 is 0. And this is the ratio of voltage to current. So ratio of voltage to current is a impedance, but it is called transfer impedance. So it is called transfer impedance. This is called transfer impedance with receiving end as short circuited. Now another parameter D can be defined in this condition. This is from equation 2. You can write D is equals to I1 divided by I2 minus I1 by I2. This will be when V2 is 0. Now this is I1, this is I2, this is the ratio of current. Okay, this is the ratio of current, and this is I1, this is I2. That's why it is called transfer reverse current ratio. Reverse current ratio with receiving end as short circuited. So in this way you can define these 4 ABCD parameter, that means 4 transmission parameter A, C, B and D. A is the ratio of voltage and D is the ratio of current, and C is actually admittance and this is actually a impedance. Okay, now I will give the condition of reciprocity and symmetry of a two-port network in terms of transmission parameter. So condition for reciprocity. Condition for reciprocity. Here the transmission parameter T is given by A, this is B, this is C, this is D. This must be equals to 1. So if this is equals to 1, then you can write that AD minus BC must be equals to 1. So for reciprocity of a two-port network, this must be equals to 1. So this condition, if this condition is fulfilled, then the two-port network can be called as a reciprocal network. Now condition for symmetrical network. The condition of symmetrical network, these two A must be equals to D. So if A equals to D, then a two-port network will be symmetrical. So this is the information that you need to solve various type of problem in GATE, in B.Sc or various competition exam. Okay.